Hey, so we're going to go over some pretty basic stuff about how to do arithmetic with complex numbers. Um, because adding and subtracting are so simple, I don't really think that those are worth going over, but we are going to do some division and some multiplication that kind of gets sneaked in along the way. So what we want to do is evaluate these expressions, write them in the form a plus bi. This is a long-winded way of saying just find the answer. For the first one right here, numero uno. First, I'm going to turn this into 1 over 2 minus 3i because that's what the negative 1 power means. In order to evaluate this, I need to multiply by 2 plus 3i on the top and bottom, because if I don't do that, the division is going to be impossible to evaluate. Remember, conjugates, right? I need to multiply by the conjugate of the bottom. So this is going to become the top. In this case is easy. It's simply 2 plus 3i. And on the bottom, this is where the magic happens. It's going to be 4 minus 9i squared. And if I really ate my Wheaties this morning, I know that that's 9 times negative 1. So that's really going to be plus 9. As in 4 minus 9 times negative 1, 4 plus 9. 2 plus 3i over 13. Now, I know right in the form a plus bi, this is just like instructions from a problem that's copied from a problem book. I don't really care if you say that this is the final answer. That's totally fine with me. But in the form a plus bi would be 2 over 13 plus 3 over 13i. Because this is such a common way of writing the answer, I'm going to say, let's just use this whenever there's an issue of like, how do you write the answer? I'm just going to say, we'll write it as the real part plus the imaginary part. Okay, cool. So that's the first one done. Negative 3 plus 5i over 15i. It seems like there is no conjugate to multiply by because the complex number on the bottom doesn't come in two pieces. But when you think about it, we also don't have a way of dividing by a single imaginary number. So we are still going to do conjugate multiplication here. It's just going to be times, well, let's see, do we need to do times negative 15i? I guess we can do things a little smartly here and just say, we'll cheat a little and just multiply by 15i. Because after all, that will still turn it into a real number, won't it? It'll just be the negative of a real number, which is fine. We're all adults here. So negative 3 times 15i is negative 45i, plus 5i times 15i is plus 75i squared. I'll change that in a second. And then that's divided by 15 times 15. Yes, it is 225. 225i squared. And just because I'm having that kind of a day, I'm going to make that negative 225 right away. Okay, this right here, the 75i squared, that's going to be negative 75, isn't it? Head's going like this, yes. So this is negative 45i minus 75 all over negative 225. And now I'm going to clean it up and get it into this form, a plus bi. It's going to be negative 75 over negative 225 minus 45 over 225i, or minus, let's see, minus 45 over negative 225i. And this is just way too many minus signs. And also there's a ton of reducing that can be done here, like 75 over 225, that's actually just a third. So this first one, the minus signs go away, and 75 goes into 225 3 times. So that reduces down to positive 1/3. And then 225, well, maybe if you've done some like unit circle style stuff, you might know how many times 45 goes into 225. But if you think about it, you'll see that's 5 times. 40 times 5 is 200. 5 times 5 is 25. These minus signs also cancel out. So this is going to end up being plus 1/5 I. Easy, right? Okay. For the last one, it's not that much more difficult. The only complicating factor here is that there's a multiplication to do on the top at the very start. So instead of leaping right into conjugates, we're going to say this is going to be equal to 3 minus I plus 6I minus 1 plus 6 is plus 5I, and then minus 2I squared over 2 plus I. Yes, the I squared turns into -1, but, you know, have mercy on me. I'm doing a lot here. So 3 plus 5I minus 2I squared, that becomes minus 2 times -1, which turns it into a plus 2. So this really is plus 2. And that means this is 3 plus 2, which is 5, plus 5I over 2 plus I. At this point, it's ready to be multiplied by the conjugate of the bottom because it's become the same form of problem as the other ones. So this is going to be multiplied by 2 minus I over 2 minus I. Now it's the same process as before. So 10 and then minus 5I plus 10I minus 5 plus 10 is plus 5I. So that's plus 5I and then minus 5I squared over 4 minus I squared. Yes, sometimes I go right to the -1. Sometimes I write I squared. I don't have any explanation for why I do it one way sometimes and the other way other times. I just like to keep it interesting. Minus 5I squared on the top is going to turn to plus 5 because I squared is -1. 10 plus 5 is 15 plus 5I over 4 minus I squared. That's 4 minus -1. So this turns into plus 1. That's over 5. And then 15 over 5 is a nice easy 3. 5I over 5 is an even easier I just by itself. So no matter how complicated the problem is, even if you have to do multiplication and then division, it yields to a pretty small amount of effort as long as you know what you're doing.